This is the second video then about representing the electronic character or makeup of an atom. And so these are known as electron configurations, what I'll be showing you today, and two types, full and abbreviated. Now, it's very useful to have your periodic table in front of you because once you realize how these are done, you should be able to actually use your periodic table, locate the atom of interest, and just from the periodic table read off the electron configuration. A component of that is making sure you know what blocks are, and just quickly remind you, the S block, that 2-column block here, the P block, is 6 columns. On the other side of the periodic table, we have the D block, these 10 columns, and then down here at the bottom is the F block. So as long as you remember those, and recall the Aufbau principle, building up, and Hund's rule, and all those sorts of things, you will be able to actually look at an element's position on a periodic table and write off the electron configuration. So let's have a go. First of all, this is the general format for an electron configuration. It's not surprising. You have to show what element it is. Don't forget the colon. Again, you're representing something specifically. You have to be specific. This number here represents the energy level for a given electron or a group of electrons. This, as you probably guessed, indicates the orbital. And typically we talk about that orbital as subshells. You can break it down into individual orbitals, but that's not very common. And this superscript represents the number of electrons. And so if we quickly look at this particular electron configuration, this is helium. Helium has 2 electrons. Both those electrons are found in the first energy level, n equals 1. They're found in the s orbital. Is there only an s orbital at n equals 1? So there's the s orbital. And there's 2 electrons in that s orbital to make up helium. If there's a 1 there, it would have been hydrogen. So if you have a energy level diagram in front of you, you can also read off that, but you don't really need to. So let's look at fluorine with 9 electrons. So there's the colon, and I'm going to start from there. So first 2 electrons, again, Aufbau, building up 1s2. Next 2s2. Next 2 electrons are found in the 2s orbital. Now we're into the 2p block, and we have 5 electrons there. And so there is an electron configuration for fluorine. Not really that difficult. Argon, 1s2, 2s2. Remember, argon has 18 electrons. 2p6. By the way, that's the electron configuration of neon we just did there. 3s2, 3p6. Now how do we know we're done with argon? Well, argon has 18 electrons. Just count. 2, 4, 10, 12, 18 electrons. So that is argon. Nickel, 28 electrons. So we're getting into the D block here. So 1s2, 2s2, 2p6, 3s2, 3p6. We just made argon. Argon to nickel, we have to add another 10 electrons, I believe it is. And so 4s2 into the 4s block. Now remember, we're into the D block, but it's the 3D block. So it's going to be 3d8 to get our last 8 electrons. So that's the only thing you remember you have to worry about when you're into the D block. It's 4s, then 3d. Now, it's just as correct to represent this way. 3d8, 4s2. I've seen both ways represented. It doesn't really matter, provided you do not have a filled D subshell, and provided you have the filled 4s subshell before you have the D subshell. So that's what is known as the full electron configuration. Let's look at germanium. And like I said, you should be able to read it off the periodic table here. So here's germanium with 32 electrons. So where do we start? N equals 1. And we're going to, germanium is right here on the periodic table. element 32. So we're going to start at n equals 1. So we just start going. 1s2. Now we're over here. 2s2, 2p6. That's neon over here. 3s2, 3p6, argon, 4s2. We're right here. Calcium, and now we're into the 3D block. So that's 3D, and it's filled, 10. And we're back now into the 4p subshell, and we have to put in 2 electrons, so 4p2. So as I said, you should be able to, once you have a periodic table in front of you, basically read these off as you go. So, abbreviated electron configuration, that's what's next. Simplification of a full electron configuration using the implicit electron configuration of, well, of what? Well, of this, of the noble gas that precedes the element. And so in this case, if we look up at the example, calcium is the element of interest. And so if we go to the periodic table and have a look, we go backwards. So we go back past potassium, and then we go to the next noble gas, and that's argon. So this is what I mean by the implicit electron configuration. That is the implicit electron configuration of the noble gas that precedes the element, argon. And so what we do then is add any electrons subsequent to that noble gas. And so calcium has 20 electrons in it. The noble gas, argon, has 18, so we're adding 2 extra electrons. So these are basically the valence electrons for calcium. Now that's not necessarily always the case, but let's go back and look at the examples we already did. So fluorine. Well, what's the noble gas that precedes fluorine? Fluorine is element number 9. The noble gas that precedes fluorine is helium, element number 2. So we have helium with 2 electrons. So now we're into the n equals 2 energy level. So it's going to be 2s2, 2p5. And so again, that is the valence shell for helium. How about argon? Well, what's the noble gas that precedes argon? I'll give you a hint. It's not argon. It's neon. So we have to put neon, and then we put all subsequent electrons. Neon has 10 electrons, so we have to put 8 more. Whoops. And so we're in the 3rd energy level, so that's n equals 3. So 3s2, 3p6. So that would be the electron configuration, the abbreviated electron configuration for the noble gas argon. Now let's try this one. Nb. Do you know what Nb is? Well, Nb is niobium. And niobium is element number 41, so it's right there. And so again, using the periodic table, we can read the electron configuration. But if we're doing abbreviated, there's the noble gas we want to use, and that's krypton. So it's Kr, square brackets, again, that's the specificity I'm looking for, and we have to add these electrons. So this is, let's just make sure we have our energy levels correct. So we're going to go after krypton, it's 5s2, and then we're into the D block, but remember this is 4d, so it's going to be 4d2. And so there's the abbreviated electron configuration for niobium. So abbreviated can be quite a bit simpler. Now, just a couple more to practice. How about chromium? Let's do the full electron configuration for chromium. So again, as an exception, chromium, colon, 1s2, 2s2, 2p6, that's neon, 3s2, 3p6, that's argon. Now remember, chromium with 6 more electrons to go. Argon has 18, we have 6 more, and the exception is that the s subshell only has 1 electron, so 4s1, and the 3d subshell is half-filled, 3d5. So again, there's an electron configuration for one of the exceptions we talked about in the previous video. That's chromium. How about the Abbreviated electron configuration for another exception, silver. That's Ag, so Ag square brackets. So we go to the periodic table and we look for the noble gas that precedes it, and that is krypton, Kr. And so krypton has 36 electrons. Silver has 47, so we have to add 11 more. And again, silver lies in what would appear to be the 5th energy level. So we're going to go 5s2. Now we're into the 4d block. And we'd go 4d9. But remember, this is an exception. So it actually ends up like this. Remember what we do for that exception? We end up going 5s1, 4d10 to give us the filled d subshell. And that concludes this video on electron configurations.